Hi everyone, in this video we are going to discuss how to solve partial differential equation with the help of Jacobian method. This question asked by the student in the comment section. So we are going to discuss its solution with detailed steps. This will help you to understand how to solve any partial differential equation with the help of Jacobian method. So to solve this partial differential equation with the help of Jacobian method, firstly you need the function f, which is a function of variable x, y, z and ux, uy, uz equal to 0. But here this contain p and q. So we have to convert this p and q in the form of ux, uy, uz. So how to convert? There is a conversion term p, we can write minus ux by uz, and this q is minus uy by uz. So here p and q, if we put this value in this equation, so here it is a p square, that means negative term square we have to take. So the p square, that means this term square, you will get ux square divided by uz square plus of q square. So again take the square of this term, so negative term square it become a positive, so it become a uy square divided by uz square into y minus q. Again here there is a negative terms and here also it is a minus, so minus of minus become a plus when we put the value of q. So it is already negative, that's why minus of minus plus uy divided by uz into z equal to 0. Now here it is denominator is uz square, so if we multiply throughout by uz square, here in this bracket you can take uz square term common, so multiply by uz square. So take this term outside, this denominator is same, so if we take outside and multiply by uz square, so that outside term and this term will be cancelled out, so you will get here ux square plus uy square y plus, here we are multiplying by uz square, so uz square and here denominator is one uz there, so one uz will cancel out, so you will get here uy uz into z equal to 0. So you will get this function and that is nothing but our function f. So we can say this is our function f. So why we finding this function f? Because we are using the Jacobian method, and in the Jacobian method auxiliary equations are, here it is a dx divided by f lower suffix ux, lower suffix representing here partial derivative of function f with respect to ux. Then next auxiliary equation is dy divided by f uy equals to dz divided by f uz. Next is dux divided by minus f x equals to duy divided by minus f y equal to duz divided by minus f z. So this is the auxiliary equation in a Jacobian. So using this auxiliary equation you have to find ux, uy, uz, because we want the solution of this differential equation, and the solution, we can say that the solution of this differential equation is nothing but du, that is a ux dx plus uy dy plus uz dz. So if we integrate this differential equation, so you will get the final solution of this partial differential equation. And to find this ux, uy, uz, you have to use this Jacobian auxiliary equation. Once we get ux, uy, uz, to put this value in this term, if it is a constant then very easy to integrate. If it is a function of x, this one is a function of y, this is a function of z, then we can integrate and find the final solution for this partial differential equation. Now for this auxiliary equation you need a partial derivative of function with respect to ux, similarly uy, uz, x, y, z. So one by one we are going to differentiate this function with respect to this variables. This is our function f. Now you have to find one by one these values. So if we differentiate function f partially with respect to ux, so differentiate ux, here is a ux term, so derivative of this term is 2 ux into outside there is a y, and here when we are differentiating partially, so the remaining term is constant, so that's why this derivative is 0. Here does not contain ux, so again the derivative of this term is 0. Only find the derivative of this term, so it is a 2ux, and y is in multiplication, so multiplication term keep as it is. Now next is you have to find out uy. So if we find partial derivative of function with respect to uy, so take the derivative of this term, so it is a 2uy into y, and here also there is a uy, so derivative of this term is 1 and multiplication term is as it is, so uz into z. Next you have to find derivative of function with respect to uz. So if we find derivative of function with respect to z, so z not uz is not contained here, but this second term contained. So derivative of uz with respect to uz is 1 and multiplication term remain as it is, that is a uyz. Now next task is you have to find out partial derivative with respect to x. So if we find with respect to x, so this term not containing x, that's why its derivative is 0, because when we are differentiating partially with respect to x, so remaining variables are constant and here all are constant, so derivative of constant term become 0. Now next partially differentiate with respect to y, so y contained here, so derivative of y with respect to y is 1 and multiplication bracket remain as it is, so ux square plus uy square as it is. Now next find out partial derivative with respect to z. Z contained here in the last term, so it is a uy uz. Now all 6 derivatives we have, so put this value in this Jacobi and auxiliary equation. So we will get dx divided by here 2uxy equal to dy divided by here 2uy into y plus uz into z. Dz divided by next term is uy into z equal to dux divided by here it is a 0 and duy divided by this term, but here it is a minus sign, so you have to take with minus sign, so it is a minus ux square plus uy square equal to the next last auxiliary equation is duz divided by uy uz. After this step you have to take the any auxiliary equation to find ux, uy, uz. So obviously ux find out करना है, you have to take this one with the combination of other any auxiliary equation. Then to find uy we need this one and uz we need this one. So to understand how to take auxiliary equations, I will rewrite this equation in the next. So see, these are our 6 auxiliary equation. Now how to solve this auxiliary equation to find ux, uy, uz? Here take the auxiliary equation ux. So here this auxiliary equation, if we take dux by 0, using this auxiliary equation you will get dux equal to 0, and if we get dux equal to 0, so can we integrate this term? Yes, we can integrate this term easily. So integrating both sides you will get integration of ux equal to integrating constant a. Now integration of dx is x. Similarly here integration of d of ux, so you will get here ux equal to a. So we get the value of first ux. Now take the next auxiliary equation. Now here this one is simple uz. If we take this auxiliary equation equal to this one, because all are equal, so you can take any auxiliary equation. So here this third auxiliary equation and last one if we take, so we will get dz divided by uy into z equal to here right side last auxiliary equation is duz divided by minus uy uz. See here this both denominator you containing uy, so you can cancel out that uy term, so uy get cancelled cancel out. So remaining is here dz divided by z equal to duz divided by minus uz. Here uy get cancelled, so remaining is minus uz. Now see here variable are already separated. That means we can integrate this term to find the answer. And this negative term you can shift in the left side, so it become a positive. So in the next step, integrating both sides, so you will get integration of dz divided by z, and this negative term shifting will be plus integration of duz divided by uz plus integrating constant. Both integration giving the answer in the form of log. That's why we consider integrating constant in the form of log b. Here constant first we are taking a, so the second we are taking log b. So solve this integration. So integration of 1 upon z is log z plus integration of uz is log uz equal to log b. If we use the property of log, then log a plus log b is log of a into b. So using the property of log, we can say it is a log of z into uz equal to log b. Hence taking antilog on both sides, so z uz equal to b. But if we want answer uz, so for uz this z if we divide, so you will get uz equal to b upon z. So this is the value of uz. Now we know the ux, uz, remaining is uy. For uy you can solve this equation, so you will get the value of uy. Here this uz square if we convert it as a constant into a, so this is complete function of uy, and this uy if we shift here, then again it is possible to solve. But problem is that you will get this uy in the form of z. If we solve this one, it is possible and you will get the answer, but it is giving the answer of uy in the form of z. And lastly we have to find the complete solution. That complete solution contain uy dy, that is the integration with respect to y. So that will be not possible to integrate. That's why we are not taking this two part. So this one if we take the combination with this, again it is possible to solve. But if we solve this one, so you will get the answer in the form of uz, and uz you have to put this answer. So again it will be taking the time and it will be complicated. So instead of solving this auxiliary equation, you can put this value in our given equation. That means in this equation if we put this value, so you will also get the value of uy. So see here from our given differential equation, here our equation is ux square plus uy square whole into y plus uy uz into z equal to 0. Put the value of ux and uy. Ux is our a square, uy square into y plus here uy again you have to find out, so keep it as it is. Uz is b by z, so b divided by z into z is there, so this z get cancel out. So you will get here, open this bracket, so I will write in the form of quadratic equation of uy. So it is a uy square into y, this y if we multiply in the bracket, so it is multiplied to each term of the bracket term, plus here uy into b, and this is a square y equal to 0. In short, it is a quadratic equation in the form of uy. So obviously when we solve this quadratic, so you will get the two roots. So to find uy, so quadratic equation roots are minus b plus minus b square minus 4 ac. So a means here coefficient is y and c is this one a square y divided by twice a. So twice a means this is a y term. Now here this is minus b plus minus root of b square minus 4 a square y square divided by 2y. So hence we get the solution of uy, but it is containing two answers. It is for plus as well as minus. So we will solve for plus minus both. So you can note down the value of ux, uz and uy so that you can understand the complete solution. Once we get the value of ux, uy, uz, then next step is final solution of differential equation. The final solution is, it is a du equal to ux dx plus uy dy plus uz dz. Now put the value of ux, uy, uz. So you will get du equal to ux is a dx, uy is this one. So I will put for plus minus both. So minus b plus minus root of b square minus 4 a square y, it is a y square divided by 2y into dy plus dz plus uz is our b divided by z dz. In the next step, integrate both sides. Complete solution means you want u equal to function of x, y, z. So integrating both sides. So integrating both sides, you will get integration of left term, that is a integration of du equal to constant we can take outside, integration of dx plus integration of minus b plus minus root of b square minus 4 a square y square divided by 2y dy plus b is constant, integration of dz divided by z. See here we can find the integration of du, dx and 1 by z. So here integration of du is u equal to a into x plus this second integral we have to use trigonometric formulas to solve this integration, because direct integration of this second term is not possible because it is not in a standard form, plus b integration of 1 upon z is log z. Now the task is how to solve this integration. So here separately I am going to solve this one. So consider this is our equation, any equation. Let's suppose it is a equation 1. Now here to solve this integration, if you observe this bracket term, it contains b square minus 4 a square y square. So here our term integration contains minus b plus minus b square. From this root take the b square common. So if we take b square common, so you will get minus b plus minus b root of, as we are taking b square common from the root, so root of b square means outside it become a b, 1 minus 4 a square y square divided by b square divided by 2y. And we know that 1 upon y is possible to integrate. So from base if we separate this term, so you will get here, this is a minus b divided by 2y plus minus b root of 1 minus 4 a square y square divided by b square whole divided by 2y. Now this one is possible to integrate, and here we have to put the substitution. So here suppose we consider this is our I. So here integration I become minus b divided by 2y dy plus minus b is constant, take outside, integration of root of 1 minus 4 a square y square divided by b square whole divided by 2y dy. Here minus b by 2 constant outside, it is a log of y plus minus b as it is. This term we have to put 2ay divided by b as a sine theta. So 2ay divided by b, from this term I am taking 2ay divided by b is sine theta. So from this term we can say 2y become b by a into, because this 2y we keep as it is, so remaining constant shift in right side, so you will get b by a sine theta. And derivative of this term, so derivative dy become b divided by 2a For derivative, again this 2 you have to shift in right side. So b divided by 2a, derivative of sine is cos theta d theta. Put this value in this integration. So I will consider this whole term as a I1. So our I1 become b integration of root of 1 minus, this whole term is nothing but sine square theta divided by 2y. Here y is our, here 2y is our b by a sine theta. So 2y is b by a sine theta, and dy is b by 2a cos theta d theta, cos theta d theta. So this is the substitution. Now in the next step, if we cancel out this b by a, so numerator denominator b by a get cancel out. This 2 is a constant, we can take outside the integration. So outside become b by 2. Integration of 1 minus sine square theta, 1 minus sine square theta, by trigonometric identity it is a cos square theta, and root of cos square theta is cos theta divided by here sine theta into cos theta d theta. Cos theta into cos theta, it become a cos square theta. So b by 2, it is a cos square theta divided by sine theta. Again use the trigonometric identity to solve this integration. So here b by 2 integration cos, we can write 1 minus sine square theta divided by sine theta d theta. It is a d theta. Separate this integral from base. I will rewrite this I1 integration in the next step. So to solve this integration I1, we have to separate this term. So here we will get b divided by 2 integration of 1 upon sine is nothing but cosec theta minus sine square theta divided by sine theta. So one sine is remain, sine theta d theta. Now integrate this term. So integration of cosec theta is nothing but log of cosec theta minus cot theta minus integration of sine. Integration of sine is, it is a minus cos theta. So there is already minus, so minus of minus plus cos theta. This is the integration I1. Put this value of I1 here, so you will get answer I, that is a minus b by 2 log y plus b by 2 log of cosec theta minus cot theta plus cos theta. But we want answer in the form of variable x, y, z. So what is the value of theta? Here substitution is 2a y by b is our sine theta. So using this term we can say that theta is our sine inverse of 2a y by b. So put this value here. So you will get I equal to minus b by 2 log y plus b by 2 log of cosec theta, theta is our sine inverse of 2a y by b minus cot theta. Again put the value of theta here. So cot theta is sine inverse of 2a y by b plus cos theta, theta is again sine inverse of 2a y by b, and this value integration I we have to put here. That will be our complete solution for this differential equation. Means given partial differential, firstly we have to convert in the form of ux, uy, uz. So for that we are using this p, q. So p is ux by uz, q is uy by uz. Put this value in this given differential equation, so you will get the function that is called function f, and differentiate this function partially with respect to x, y, z, ux, uy, uz. So you will get this auxiliary equation. It contains 6 auxiliary equation. Using this 6 auxiliary equation, you have to find ux, uy, uz. Ux must be in the form of x, uy in the form of y, uz in the form of z, so that you can possible to find a complete solution. So when we solve, you will get this 3 answer, and complete solution form is, it is a du equal to ux dx plus uy dy plus uz dz. And once you put the value of ux, uy, uz, after that you have to integrate this term. So integration, here I1 I have already put the value of I here, so that nothing but the complete solution for this differential equation. Thank you for watching.